So one of the reasons that we like to talk about performance-based design and setting these goals is that what often happens is people bring us a completed set of plans, plop it on our desk and say, help us make this energy efficient. And at that point, not the only thing, but what tends to happen is that it ends up costing more. You know, you have to, because the design's already set, you have to add things to it in order to make it energy efficient. Whereas if you start from the very beginning and set the goals, and design around the goals, then you can do it much more cost effectively, rather than just having to add more stuff, right? So that's why we really push this whole performance-based design concept, because we get pretty frustrated with people dropping plans on our desk, and we have to, all we can do is, or not, once again, not all we can do, but what often happens is the things that we suggest that they do end up adding a lot of cost to the construction. And you can build energy efficiently for a very reasonable cost if you start with the energy goals in mind.
One of the last performance goals that we could set would be net zero energy. And the easiest way to do that is to design it with that in mind. The passive house standard, with the aggressive envelope details that they look at, is definitely the biggest step towards net zero. And then the final last little bit made up, you know, for what energy they do use. To bring it to net zero, there's a small amount of renewable energy. A lot of times we see people wanting to put ground source heat pumps in, or solar panels, or solar thermal systems on their buildings, but the net effect of doing that in our climate is minimal compared to insulation, air sealing, good windows, good shading, passive solar design. All of those other things besides the ground source heat pumps and solar panels has way more effect than the solar does. So we like to see the solar and some of those other technological components to be the last part that gets added to the project.
Yeah, reduce the energy use down to the minimum first, and then look at how you're going to replace fossil fuel energy with alternative energy. That's our approach.
So the different ways to gauge the energy performance, the Energy Star program is prescriptive. Basically, if you do this R value in the floor and this in the walls and these windows and this type of heating system, you get the Energy Star label. The code, we're going to get into that more in a little bit, but it has a number of different options, doing the prescriptive or using an energy modeling simulation type software. The different improved performance goals, we have to use a simulated software to be able to compare it to code. REMrate is one of the residential modeling programs used for the tax credit for the 2030 challenge. For showing, or even for the new code, actually, it can be used to simulate performance. So that's 2030. Passive House Standard, they have their own software that is pretty difficult to learn on your own. My dad, actually, I sent him to the Passive House training. It was 9 days worth of training in three days, 3 different times. And most of it was spent learning how to use the modeling software. It's extremely detailed. They look at every single thermal bridging detail. You have to actually model the frames on the windows to show how much energy is lost through the frames. It's from our experience, we feel like it's the most accurate, as accurate as any energy model can be.
But of course, it's only as accurate as the person running it.
Yeah.
You know, so you definitely need to know what you're doing.
Yeah. So the net zero would require, one of these different types of simulation softwares as well.